second part for the real hand-on training that everybody got the IP address. Yes, online also. Online they got. Oh, nobody they left for it. But anyway, just you could start, and then I'll be back. I need to go to the working group share meeting a little bit, and I will come back. Okay.
Hello, everyone. I'm Charlotte Xu. I'm also in the satellite image data division in TASA. And in the hand-on practice in this section, I'll give some introduction and some practice about how to use the data queue with the Jupyter Notebook. And there's also some fundamental application for the remote sensing data. And there's a introduction about using QGIS to connect to the web service to take a look at the data in your open data queue. So I think everyone has got the IP address. Do anyone else haven't got the list? Oh, okay. Okay. If you got a list of IP, you can just log in according to the IP address here. Here is the address. The XX here is the IP address you have to key in, and A0 port is the route to log in the Jupyter Notebook. And the password, I think everyone is the same. Yeah. Okay. I will also follow the step. Oh, one. So if you log in successfully, then you can see the interface just like this. So if there is any problem, yeah. Yeah. Okay. Do anyone need help or need much more time to log in? Oh, okay. Any problem? Okay. Wait a moment.
But there is no connection.
There is no connection. Yeah. Let's get another one.
Okay, I see someone is okay.
Yeah.
Oh, you are okay, okay. Okay.
Yeah, I think so.
Because right now we're using IP, right? So okay, you are okay right now.
Yeah, just logging the password. Okay, thank you.
Okay.
Oh, there's also a Wi-Fi that's supplied from APN. Then
APN57,
yeah.
And the passport is also APN57. And
this is a hotel. You need to select.
Oh,
yeah. But before they give you a APN Wi-Fi. So select different one.
Oh, okay.
If APN is using SSID, you take.
Yeah.
Okay.
For hotel.
Okay.
But
Yeah.
I think everyone's okay.
Yeah. Everyone can use it.
Okay.
Okay. Yeah, I think. Yeah, I think everyone logging in right now. You can continue.
Okay. In this interface, you can see there's a folder name APN workshop. You can just go inside, and this is whole the programming and the PPT slides we will talk about and share to anyone. So you can just click the PPT slides folder. This folder, and here is the PPT slides for the introduction part that Dr. Zhang just gave you in the last section. And there's also the hand-on practice PPT introduction here. You can just download all the PPT slides and follow the step we will do today. Okay. For the programming, let's come back to the 00-APN55 workshop, this folder. Okay.
Better.
It's better. Yeah. For the hand-on practice section, first, there are three programming we will introduction about, and this is A001. This is the first program we will introduction. It's a fundamental program that will. Oh, okay. Okay. Oh, thanks. Yeah. For the first programming, there's a fundamental application to introduction how to import the remote sensing data from the service queue to your private queue. And there's a function called custom mosaic that is used to give a simple management for the optical image data that may be affected by the cloud. And in the second program, it's a lens light detection using the sleep product. It is I think we will introduction more about it. Actually, Dr. Zhang has already give some brief introduction about it in the previous introduction. Yeah, and the lens light detection can also be realized through an AI model. So in our programming, there's a folder called A003 Lens Light AI. It's another way to detect lens light action area through an AI model. In this folder, there are two parts of it. One of them is for the AI model training, and another one is for the AI model prediction. But for the first program for AI model training, actually it will take much more time. I think it cannot be run in this lecture. So we will just give an introduction about the code and yeah, for prediction part, I will let everyone to try a well pre-trained model for the prediction and validation. And then the last one is the ODC web service. Actually, Dr. Zhang has already given the introduction about that. We will use the QGIS software to give a look at the data that have already be ingested in your private data queue. So I think we can just go to the first program here, A01 custom mosaic. Yeah. Please just double click it. Yeah. Okay. Yeah. Okay. Okay, I think everyone has opened this Python code. Okay, I think we can start it. When I just give a introduction about all these scripts, I think you can follow the script and give run it. For running this program, you can just click here. Run. Yeah.
Click the play.
Yeah.
The icon.
Yeah, this
play,
icon.
And then you can play.
Or you can use Enter and Shift. Yeah. So for Python programming, first of time we have to import all the library we will use for the data analysis. For most of the time, there are some fundamental Python library have already been written here. Just like NumPy, Pandas, and XArray. Dr. Zhang has given an introduction. Yeah. And the matplot, and just like this for the plotting and then time, data time, just like that. But for special Python library in DataQ, we have a function called utilities, DataQ utilities. Actually, this is a function that will manage the remote sensing data and have some simply application using the satellite image data that was developed by Geoscience Australia, I think, right? Yeah. If you actually when you install the environment of DataQ, this function will also be stored in the Jupyter notebook. So we can come back. If we come back to the interface, I think yeah, here is the folder. Yeah, utilities. You can just click here and in this folder. You can see there are so many pre-installed Python code here. Here is the special program that are in charge of remote sensing data management. Yeah. So you can, if you want to find out some function that is used to manage or for the remote sensing and analyze, you can just take a look at the programming in all this Python code. Okay, let's jump back to our program. So for our training today, we also include some special program that is specialized for DataQ now. And here is some function we are already prepared for image data output with the natural color in RGB. So as you can just run it. And for the custom mosaic tool that we'll introduce about today, it depends on the cloud mask we will define for the optical image data, because we knew that optical image data is affected by the weather, just like a shadow or cloud or I'm not sure. Just like this, and for different optical remote sensing data, there are some definition for the pixel. For example, in this practice, we use Formosa 2 as our practice. If they are imported into DataQ, they will be translated into ARD data we have already talked about, and it has the special quality called quality QA here, pixel QA. It is they use the number to labeling in each image data, which quality it should be belongs to. Just like for the Formosa tool, we use number 2 label as a clear pixel, and for we use number 4 to label the pixel that contain water as water pixel, and we use number 8 as a shadow pixel. So for a cloud mask, it is used to to skip out the data that may be affected by cloud or shadow or something that may be invalid for the analyze in our program. So in this so we use this function definition to remain the pixel one we will use for analyze and skip out the rather affected pixel.
Okay, so right now the custom mosaic means that we want to aggregate a period of images, because for one specific image there's always cloud. So if you want, if your analysis allowed to use a period of image, then we can aggregate those images inside that period and only take those pixels without cloud and then put them together. Then you will have a no cloud image. That is the purpose of this custom mosaic. So that's why we can know where is good pixel, because we have cloud mask. Before we put an image into the database, that we have classified clouded area already. So we have the information of cloud and can get rid of those clouded image.
Okay. Then the question is the range. If it's too long, I mean, like you need 3 months to do it, but you want to study this week. So it's going to be the contaminated pixel that is not represent the period that we would like to study. Do you know which pixel is the pixel from different date?
Yeah. So the first one, you have to select valid period that is suitable for your analysis. For example, if your analysis want to know seasonal changes, so you can aggregate a season's image. But if your target period is 1 week, so that means you can only use 1 week's period to aggregate your data.
Right.
Okay. And what was your question?
No, the thing is, like in 1 week, it cannot be complete cloud-free image.
Oh, yeah.
Very difficult.
Yeah.
So if you want to study 1 week, but you need 3 months of image to complete, to be clear, you have clear image. So it's over your study time. Then can you tell, the system can tell or not which pixel come from which date?
Actually, that's your next one.
Okay.
So the next, once you select proper period, that has to be according to your your objectives. But once that is selected, the next one is, if I have many choices over this period, which pixel will be taken out and put into your final result? That is the next one. Get more recent pixel.
I had a problem before and very difficult to, like, for the forest phenology, when the phenology happened, but you're using the composite cloud-free image, but you don't know, like, for example, that if you would like to detect the burn area, but in order to have complete image, you need 3 months, but the burning is already, happened
within a month.
Right, something like that. So it's very difficult to explain if we don't know which pixel. Because when the Google engine came out, they used the greenness to be clear then for which date.
So in this case, you have to set up proper period that you can use. You can regard it that is happened at the same time. That depends on your variation of your object. For example, maybe for wildfire, every day's data counts. So then your period will be very small. But if you are interested in some kind of city changes or urban changes, then you can aggregate long time period of images. Yeah, that means you are easier to have cloud-free image. But for the case that change very frequently or in very fast period, then you have no choice to take a very short period of data, or you can only use that certain dates. That depends on your application. But for sometimes we are I mean, for some objective, we are looking for a slow variation, like I said, urban changes, something like that. I want to know which years, I mean, where is the urban area for different time period. Then I can add a suitable long period of data. And you know what I mean? Yeah, that totally depends on your.
We had a problem before, like the crowd persistent area. Yeah. For example, Papua New Guinea, you use 4 years of Landsat, still cloud. It's like what? Yeah. Then we have to make decision in what date, what period to be suitable to show the changing of the forest for when you calculate the carbon emission, something like that.
Yeah.
So just
in that case, optical imaging may be not suitable, especially for tropical area.
But do you have the script that mixing up between the microwave and optical together to make the cloud free?
That is not easy. Yeah. One selection is just switch to star data. Switch to star data, but like,
He got PhD in SAR.
Yeah, so that is a very difficult part beyond today's class. So okay, let's finish this part. Yeah.
Okay. I think Dr. Zhang has give much more brief introduction about why we need the custom mosaic, and before custom mosaic, why we need the cloud mask. It's just the identification for an image, what pixel we want and what pixel we want to escape from it. Yeah. So for a time series of the optical image data with the cloud mask, we can use the custom mosaic to give a union for our interest area, and got a much more complete database for our further analysis. So I think this one we can just run it. It's just a function definition. And here is the function for the remote sensing data loading to our private data queue. Actually, the prepared data has already been stored in our service queue. Depends on different the remote sensing are derived from different satellites. So in this practice, we use Formosa 2 as our analysis data. It has already been stored in our service queue with the platform and the product name just like this. And if you want to, we want to change to Landsat or Sentinel image data, this name will be changed. But now let's use this one as an example. And here is the study area. We will define here with the coordinate.
And if we want to use Landsat, usually have a data dictionary that explain this.
Yeah, actually,
actually,
there's a list for it.
In real cases, we will put those data in our server queue, and then we will tell you what is the name and what is the
there's a unique name. And then here is the time interval left for the temporal image data we will use for the analysis. First of all, we'll just take a look at only one image data. So the time interval can be just defined as January 1st in 2015. And then here is also just the definition for the route of the service queue that will link to Formosa 2 data sets. And we'll use dc.load to loading the parameter that is defined here. And notice that there's a parameter called measurement. It's used to choose the spectral band we will use in our analysis. For example, for Formosa 2 image data, we have RGB and NIR band in this satellite. So we get all of the spectral band here, and we also include pixel QA for the CloudMax we just talked about. And then we'll use the CloudMax function to choose the pixel that we will use in our analysis. Okay, so let's
question for the data, for the image, what level are you using for the image? So it has to be geometric correction. Yes, there has to be,
Actually, because that is ARD, everything has to be
already prepared. Okay.
Corrected. Not only radiometric but also geometric. So for lens, for Sentinel 2, we call that level 2A survey reflection. Yeah. But right now, this is formal set, and the data here is TOAR only, not SR. Yeah.
Yeah, I think we can just run it. It'll take some time to load the data, and you can see with the CloudMax here, in the left-hand side, there are some part of pixel there's missing because we might be affected by cloud, so it will be blocked out.
That's because we only select 1 day.
Yeah, this is the time interval we only select 1 day. So, but for the analysis purpose, we will use enlarge the time interval here. So we can just change it to February 5.
A longer period.
Yeah, and run it again.
So hopefully the black area will be filled
by
another day.
Yeah, you can find that. Because in every day the image data may be a little different, so you can see there's a gap for the color.
Because that comes from different days. That is only TOAR.
Yeah.
But this is a very important automatic process because eventually we want this kind of job be done automatically. Yeah.
And after we produce the well-prepared and data, then we can take a look at the data set. We load it to our private data queue. Okay. And the result can be transferred into a GLT file and saved in the route that we define in the Jupyter notebook.
Just for later use.
Yeah, and they can be also be downloaded to your local system for other analysis. Yeah, this is the first part. I think we can go to the second one. Yeah. So
please go to Apan57 and again, second
A02 sleep. Yeah.
Because right now you are connected to Taiwan, not in Thailand, so a little bit slow.
Yeah. Okay. Do anyone log in this open this Python code? Okay, I think we can continue. Actually, this function, Dr. Zhang has given a brief introduction about it's a landslide detection. Use the sleep product. Actually, I will jump to the PPT file. I think. Oh, yeah. Okay. Oh, okay. In this practice, we will get an example about typhoon Morak. It hit Taiwan in 2009. Actually, it's a severe. It makes a severe disaster and gave a landslide and a mudslide and flood in the central or south and the southeast of Taiwan. After this disaster, the land coverage in Taiwan changed a lot. So we'll use this example to to do the landslide detection in our program. Okay, let's jump back to our program now. For Python code, similarly, we will import the Python library that will be used in our analysis. This also sends the same to the previous one. So let's just run it. And to give the analysis about landslide, we have to have two image data. One is the prior event image data, and another one is the later event image data. Actually, we'll use the difference of these two image data and give some condition and threshold to identify if this area has the landslide or there's no landslide here. Condition going to
show you the processing process by diagram.
Yeah. Okay. Yeah, I think this one is the more clear flow chart for our analysis. First of all, we will get the post image, prior event image data and the post image data. And there are three conditions that have to be satisfied. The first one is the land coverage change recognition. We use the red band for the prior and the post event image data to calculate the difference of them. And the second condition is for the NDVI difference. First of all, we have to calculate the NDVI, this normalized differential water index for the prior and the post-event image data, and then we have to compute the difference of them. And the third one, we want to calculate the slope degree for the hill or the mountain. This one we use the DEM to calculate it. For these three conditions, we will give different threshold for this condition, and if a pixel that satisfy all of these conditions, they regard this pixel as a landslide area. So this is the concept for our program. So first of all, we're just loading the prior and the post-event image data. So here, there are two time intervals here, and the longitude, latitude. I think it's very similar to our last program. Yeah, and this is also for the RGB output and the cloud mask and the custom mosaic. We just talk about. Here is the image data loaded to your private data queue. I think similar. We'll just run it. And it will take some time to print out the prior and the poster image data. You can find that for a custom mosaic, there is a gap for the color. And then we will calculate three conditions that each pixel should be satisfied. The first one is the CVA difference. And the second one is the NDVI difference we have to satisfy. And the third one is for the slope angle. So for the result, they have to get the intersection of all these conditions and show the landslide area here. The yellow part is the landslide area that we detect, which also satisfies three of the threshold. And the result of since in each image we will have the resolution for the remote sensing data. So the result can be translated into the area for the land change. Yeah, and it can also be save as the TIFF file or the PNG file and save in a specific route in the Jupyter notebook, just like this. Yeah. So I think we just finished it. Okay, do anyone has any problem about this process of landslide detection?
Yeah.
Okay.
Or if it, okay.
Excuse me, I would like to ask you for interpret the result and the scale. What is one?
Oh, you mean for the error?
Right now, we are using Formoset 2 image resolution, 8 meter. And so you can see that there is around 300 by 300 pixels over there. Yeah, right now the number that there is 9 sample. So it is around 3 by 3 kilometers area right now. That's because right now we are doing training, so we focus on very small area to make everything quick. Or we will, if not doing so, we have no time to wait.
Yeah.
Yeah. Only a very small cases to try on. But
how do you know that the images are ready for you? When do you know that the satellite passed and then they process and it's already in your system to run it? Because sometimes the data not there yet.
Actually, right now you are asking a more practical issues, not only for training, because this is training, so we know there's an image there, so we carry out everything. But in real case, you have to know is there image at the first, then you can do the following, right? So we have an API, right? Okay. In that part, actually, it's a more realistic cases. Actually, we have a query in this period. Is there images, right? Because actually we need 2 periods. For earlier period, it should be okay. But for the later image, is the newest one coming to my system right now? If it is not yet, then we can carry out our module, right? So actually, in the real case, before you set up your prior and later period, I mean, you want to analyze it, you can check if there's image over there. Then you hit process, right? If there is no image, you cannot hit the process. You have to call. Yeah, you can, because there is no later period image, you have to call TASA. Why you do not take my image? Yeah, call me, and then I will test that part right away for you, something like that. Yeah, but normally, hopefully because since the EOR, emergent observation request, will be sent at first, and follow that EOR, we will acquire our image as soon as possible. Yeah, that's the scenario. Yeah.
The result or algorithm that detected, for example, this one, landslide. Did you do the validation that how accuracy of the result?
No. Yeah, okay. because for this one, that is we saw how we call that EVAP, emergent value added product. That means there is no time for validation because we have to send this kind of result as soon as possible to the emergency response agency.
Right.
So actually, we don't have time. But in a later, actually, we can check if there is a field survey carried out, then we can compare.
The thing that I am asking that you have to adjust if it's not correct and the accuracy too low, you have to adjust the algorithm to fit it more.
If the accuracy is not high to a certain standard, then it will cause trouble to the response teams.
That's right.
Yeah. So actually, that's why we use change detection, not use single image processing. Of course, you can from the later image, then you can know visually, for example, where is landslide, something like that. But sometimes you really need to have earlier image and then use change detection, something like that to know if this change is happened during this certain times. That means that you cannot take the image too early years or days or something like that. Then the change maybe not happen because of this event. So actually we will focus on our earlier stage and later stage as close as possible to make sure that detected result is due to the event. Yeah, something like that.
People on the ground, when they get this result, it has to be some extent to tell them that the accuracy. So the commander at the scene understand that this quality of the product of the product and use it. If it's like totally off, gonna cause a lot of trouble because the people in the field will deploy differently. So it's like
So you if there the accuracy too low, you will cause trouble. That's what I mean.
Right.
So actually, before we deliver this product, we will take a look manually again to see if the detected result just follow or is consistent to your observations. I mean, but as you know, if there is a result, manual observation can be very quick. Yeah. So actually, do we use QGIS? Do we have a demo in QGIS for this one? Okay, maybe we can show. Maybe we can show that to you later. Yeah. But this is only
right. Just curiosity, just curious to ask.
That piece of
because
how to practice this.
The fact that we have to admit that we are in the room with air conditioning, and we just process and we send the result. The people in the field is very hot, it's very wet. I'm hungry. The result should be some kind of a high accuracy for them to use.
That's what I mean. Usually we try to avoid false alarm. Yeah, something like that, because doing this is easy in office. Field trip actually is very tedious.
Right. Actually, but I think, I don't know if we send the result like this, the people in the field, they will bring up the drone and check it again, and to make sure that it's consistent or not, something like that.
There is no time for them because they have a response according. This is the source they according to. Yeah. So we have to avoid false alarm.
Right.
I would rather to miss some part. I'm not that certain. I have to send out something. I'm certainly make sure that is happening.
Okay.
As you know, detected from satellite, there will be a lot of areas. Yeah. And in effect, is that the response team don't have that kind of ability to take it.
Not the whole area. Just when they pick some area, like what we do. Let's say for forest fire, you said this. Before you go into this, I mean, you are there, but you have to bring up like a third the drone with the thermal camera to check and double check, so you can deploy, because we don't have a lot of people.
That's why
I have a certain people there.
We will send them the one we think that has less false alarm.
Okay. All right.
Finish the second practice, and then we'll go to the third one, the landslide detection use the AI model. I think everyone should be excited about it. Let's go to there's a folder called 8003 landslide AI. And here there are two programs we just talked about for the training and for the prediction. For the training part, we just give brief introduction about it. I don't want to waste your break time. Oh, we'll just switch to the PPT slides. For the training part, we'll use the deep learning model. There's a CNN type model for the image data detection here, and this is the flow chart for our practice. For AI model training, first of all, we should have the training data set which has already been labeled by the ground truth. For the practical issue, it should be where is the ground truth come from. In our practice, we use the sleep model we just talked about to have the produce the ground truth that can be used for the training data labeling, and after the AI model prediction, it can be used for the validation. So all the training data combined with the ground truth labeling, they can be used for deep learning model training. Here, there's the structure for the model about it. And after AI model have been well trained, it can be used for other image data for the landslide detection. And after the prediction part, we will use the ground truth also produced by the sleep model for the AI model validation for the performance and the accuracy. This is this is accuracy calculation. Actually, most of the time, if the accuracy is higher, then it means the performance of the AI model is better. Here's the training data set and the testing data set we choose for our AI model. Here, the blue part we cut it as a small tile. It can be chosen as the training data set, and we only choose very small part of them as the testing data set. Okay. So for the training part, we also have to have the prior and the post event image data in each tile, and the ground truth for the training AI model training. This is the training log for the AI model training part. Because we have less time, I just skip the detail of that. And after the AI model be trained, we just choose a few of the testing data for the AI model prediction, and we'll use the ground truth that produced from sleep product for the AI model validation. This is the image data for the validation with the difference of the prediction and the ground truth. Okay. Let's just go to the predict part. Yeah, it will take much more time, I think. So let's go to prediction part. Yeah. Also, we import the Python library, and actually for AI model training, there are some special Python library, just like Keras or PyTorch. It is support AI model training and the prediction. So just run it, and this is the loss function definition. I don't want to give much more detail about it. And here we choose the training data set that has already been stored in our Jupyter notebook in the specific row here. Yeah. And just loading the data. For our prediction part, we only use one tile of image data for the prediction and the validation to save our time. And then we loaded the well-prepared, well-training trained AI model here. And it has already been stored in our Jupyter notebook. Just run it. And we want to use this model for the prediction. So just run the program here. And we also have some definition for the accuracy and for the performance. Here, it just show some accuracy. And it can also be visualized as the image data. This is also accuracy. Also accuracy for the validation. Okay. Okay, here is the visualize for the validation. Let's just run it. Okay, here you can find out the user accuracy and the producer accuracy is almost 82% and 80%. And here is the result. You can take a look. Here is just the original image data for the testing data set. And this is the ground truth. It is just a mask just like this in the original image data. And this is a prediction. Also show us the mask on our original image data. But we want to focus on the difference of the ground truth and the prediction. Here shows the difference of that. The yellow part means the omission error, and the blue part means the commission error. Okay, yeah. And I think this is the same, but we use the post event image data as the base map of as the background. So it's the same. And for the last practice, we'll use the QGIS to show the I will give. So do anyone just install the QGIS in your laptop? Or yeah. 就直接用开，直接开。Okay. So. So do anyone need time for open the QGIS? Okay. Okay. Here we have to use the QGIS to connect to the private queue that you in your VM and show the data that have already be ingested in your private data queue. So here I'll show you how to link to the private data queue in your IP address. Here, please open the label layer. Here, there's the add layer labeling here.
And layer by WMS service.
Yeah. Please click this.
Yeah, click
add
this one.
WMS layer.
Yeah, and then
What?
Your QG is too slow.
No. I will. I will. No.
Okay, in the other screen. Okay.
Yeah.
Okay.
And then you can just
add
new
capability.
All the windows should be. Yeah, you can just give it a name. Any name you like. Yeah.
And the URL.
Yeah, the name.
Yeah. And which is URL they have to input.
Here, yeah, the name you can just give a name you like, and the URL part. Here you can just key in the IP address that I just shared to you, and but for the lattice, there should be a 8000.
The port number.
Yeah,
is
the port number is
8000.
different to a Jupyter notebook.
So be careful of every number you input.
Yeah, or it cannot be connect to your VM.
Actually, we prepare this slide for you. You can download that in the Jupyter notebook.
Yeah.
In the PPT.
Here.
Yeah.
PPT slide is in the 03 data queue practice with the fundamental application. You can follow that step.
Okay. So if everything going fine, then you can click OK, right?
There's a OK.
And then you can okay. And then you can click edit and see if
for example, there's a list that has installed a link that you have already linked to the VM.
Yeah.
So for me, we use the 001 VM, the first VM in our practice.
Actually, this name is just type, right?
Yeah, it's just the name. Then you type.
Yeah.
Then you click connect.
Yeah.
Oh, great.
And then you can check the edit again.
Yeah. If there's a warning, you don't need to.
Just
I'll show.
Okay, because right now we are using IP. That is not secure,
Okay.
so there will have warning. You just skip the warning.
If there's a warning, just escape it.
Yeah, just ignore it. Ignore that. Then you will have a list of the WS capabilities provided by your data queue.
Yeah, you can click it and click add. If there's also a warning. Don't just ignore it.
Yeah, ignore
it.
Click 01. That's nice. Select, right?
Yeah, you click here and click add.
And if there's any warning, just
ignore the warning. Then just add it. And I think the image data should be imported in your QGIS interface, and just close this window.
Then the image.
Yeah, you can share
by direct capability by your ODC is there.
Yeah, and it's a time series data with two image here. So if you want to take a look at all of this image data, here's the clock here. You can click and run just like a video.
Then you can select different video. Take another temporal data. Okay. Actually, because there is only two data. One is there, another one is southern part. So there is
there are two
image over there.
We just interested in your private data.
Means the image acquired in different temporal times. Any problem? Yeah. And ignore. Ignore. Okay. Then you click the zero one. Yeah, and then add. Ignore again. Still processing. Because there is a waiting bar there. A little bit high. Let me see. Oh yeah, it's there. And then maybe you can put some layer also map, something like that. Then put it in the background. Then you know where it is. Yeah, from here. 玉讲一下那个
Okay.
OW
Yeah. If you want to take a look at where is the image data in the left hand side, there's some Google Map or Google satellites that you can select it.
put it in the background,
Yeah.
and you can see where it
Yeah,
is.
here you can become it as a best map here. Just that.
Yeah.
Yeah.
Background
To
image.
give you much more information about the image data.
Image where it is.
Yeah.
something like that.
Mhm.
Sound okay? Everyone get a WS service response? Okay, I think everyone. Okay.
Okay.
Yeah.
So we still have 30 minutes. I can give a give a brief demo for our API part. Okay. For the last part for our practice, we'll give an introduction about the third-party application with the Taiwan Data Queue. Here we'll focus on the API function that is much user friendly interface. That for the user they don't need to touch much more about the Python programming. Let's just give an introduction about the architecture of the API function here. Actually, there's a front end and the back end of the API interface. In the front end stage, it's a much user friendly part for a user to set the parameter for analysis, and it can also return the result of analysis and for the data downloading and the visualization. And the data you just set in analysis data parameter, you just key in the front end interface. They can be transformed into the back end stage of the API through the HTTP or HTTPS connection. This parameter will be transferred into the back end, and actually for the main computation part is also be installed in TWDC. So the parameter will be transferred into the TWDC for the computation. For the example for our practice, we will also use the sleep product for the landslide detection. So the parameter about the prior and the post event image data and the threshold of our three conditions should be transferred into the Taiwan Data Queue for the analysis and computation, and the result will be output and transferred into the back end stage of API, as well as a zip files here, and it can also be transferred back to the front end for the interface, and user can download it easily. So this is the structure of the API function. It's all the parameter and the result can be transferred and from the HTTP and HTTPS for the data exchange. Mhm. For API design structure, in the TWDC, it can be just expands the capability of TWDC, and it also supplies some much user-friendly analysis tool in the following way. For example, about the landslide detection, first of all, we should have the method for the landslide detection. So we have the sleep product here. The API structure is a convenient way to modularize the sleep function that have in the back end of API. It can include the image data query and the sleep detection and the result downloading. All the function can be modularized in the back-end stage of the API. And for a user-friendly interface, so we have created the front-end stage of API for the data setting and the result downloading. And the front end and back end of the API stage, they can be use the internet directly. So the concept of the API structure that facilitate the modularize of the landslide detecting process code and establish the back end API for the sleep model. And it also complete the landslide detecting system interface. Okay, this is the concept. This is we just talk about it. So we just go to the demo part. First, we'll go to the back-end page of the API. Yeah. Okay.
Because this part is the back-end part of operation, so you just take a look at our demo, and in the front-end part, then you can practice on something like that. Yeah.
For general rules, actually they will not use the back-end part. Actually, this is just for the double check for as an engineer for all the function.
A functionality test. Yeah. To test your function.
It is work
or not.
Yeah. In the first function, it is a image data query. This is the issue that just Mr. We just talk about it. For a practical issue, we have to double check whether the image has already been installed in our data cube. Yeah, so actually we should check about it. Check, yeah. So also, for example, or for a landslide detection, we should have the interest area with the coordinate and the time period for your landslide detection, and also the product name and configure name of the service cube. Yeah, let's try out it. Yeah. The default value, and then we don't need to change it, just execute it. And they will just double check the list in the data queue that whether the interest data that has already been stored in our data queue. And return the list it is the list for the study area and the time period that has already been our data cube. Okay, and this is the second module. This is the most important part for the landslide detection. Here, actually, the parameter is almost the same to our practice in A002. Yeah, the study area and the time period for the prior image data and the poster image data and the product name and the configure name of the service queue. And actually, the image data for the poster event and the prior event data can be derived from different satellites, but they may contain a different resolution. So there is a blank for define the resolution. Yeah. And we also have 3 blank for the search of 3 condition we'll use. Okay. So let's just try it and execute. Okay. This module will invoke the main function interact TWCC for the landslide detection, and the result will be saved as a TIFF file and compressed as a zip. Zip file stored in a specific folder with the name, then with a random number. Here is the name for the result, which is stored in the filter. And then the third model is the one that will double check if the result has already well saved in the folder. So we just test the number for the folder. Double check. It will return the message that will check the history log for saving the result. So they return success. It means that the data has already been stored and we save in the folder.
Yeah, that means that the process we submit to data cube is finished, and there is a ID return data, so user can start to retrieve their data. Yeah.
And the last one is for the result downloading. Here we just also give the name of the folder to save the result and just.
Then you will execute. Then you can start to download the data. Yeah.
If it's success, then you can just there's a download file. Click here.
Yeah, you can start a download. Yeah.
Download.
But actually, you don't need to do like this way. In the front end, the processor will handle this part by user.
So for the practice part, I think we can just give a try for the front end.
Yeah, the front end part. It will look more user friendly. Yeah. Go to the front end.
Just key in the IP address and A081. Yeah.
Please see if this IP can respond you this page. Yeah. The same IP, but the port is 8081. Yeah. Hope your internet don't block this port. Yeah. Okay.
It's a user-friendly interface that just have the image data double check query and for the landslide parameter in each can be set. So for image data checking, we can just choose Formosa to image data that has already been prepared in the service queue. Choose the Formosa to image data as a prior and later embed image data source. And we just want to set the study area for the landslide detection. Actually, you can use the this is the Google map to spur the interesting area here. And they will give the longitude and the latitude number in the blend. They will automatically and calculate the area, interesting area of the perimeter square.
So the special criteria is set by the tool. Is set up by that tool with a small black square. Okay. That when you click that small black square, then you can start to select your interested area. When you finish the selection, then the selected coordinate will automatically goes to the rectangle boundary. Then okay.
Then we will choose
a temporal setting.
Time interval for your part and the poster in you can choose a certain can just set a default number.
You just leave the date over there, and then suppose that's the day you want to operate, then you can click preview.
Yeah, you can double check again if there is the image data.
If there is a list, that means you have this many data that can be used as prior date image, and they check the prior later one. Yeah. Then there is also lots of later days data over there. And then we are going to use this image to perform custom mosaic and use that as target image to detect the landslide. Okay? Okay.
Number and
run the detection. Yeah. Yeah. So actually the detection is started in our data cube, and then once it is finished, it will return you the result. Yeah.
And it will download it automatically the zip file.
Yeah. So this part actually is the finished one. Yeah. Then
we can take a look
at that file. Yeah. Let's go to our local file system and then see if the file is there. Right? Okay. Okay, that is the file just downloaded after around 12:18 lunchtime. Yeah. Okay. Then you can unzip this file. Unzip the file. Okay. Unzip it is there. Then we can put this image into QGIS and take a look at the result. They are including a prior date image and later date image and the sleep result. Yeah. So we can put the data. Okay. Okay. Then let's put our source image into their queue. Yeah. And for JSON. Okay. Okay. It's okay. So, okay, then in this way, then you take out sleep result first. Take out sleep result first. Sleep result, not image. Take out sleep result, and then you can show this is the later image. Show the prior first. You can see that the river is thinner in the prior day, then is wider than in the later day. That is because of the landslide happened around the river, around the riverside. So especially that black area, Okay, okay, no. Let me put this. Yeah. Okay. So you can see you can see that, okay, the river is wider because of landslide, and the black area is the detected one. Okay, so that's what I mean. If you use change detection, it can easier to find the affected area. Okay, maybe black area is not that clear to see. Maybe we can change that to different colors. Yeah. Then we can maybe single pseudo color. Yeah. Single band pseudo color. Then one. Yeah. Rainbow. Okay. So you know where is your denser area between these two images. Okay, because you use change detection, so this kind of thing can be easier, can be performed easy, something like that. Okay, maybe you can continue practice this one. If you have any problem, you can just raise your hand and tell us. Okay. This one. I can't. Yeah. Okay. Yeah. Okay.
Can you give me the number of your
What is your VM? The number. 006. Number 6. Yeah. And 5 and 6. 5 and 6. Okay. Actually, most of the process is like what we said here. Okay. So actually, this is the end of our hand-on practice. Because there is time is not that much. 23. Okay. Yes, we will keep it open. We will keep it open until this week. Yeah. Okay. Okay. Maybe next Monday. Next Monday. Yeah. Okay. Especially for the API part, you can see that my conclusion is that for general users, you can let them to access the code. The code processing is difficult and easier to have problem. So that's why we suggest to use the API way to access the module for especially for government officer. You can let them to operate the code, of course. So this is our hand-on practice state. So if you have any problem or question, just tell us. Yeah, the training material is also on the VM. You can download that anytime you want to do that. Okay. Yeah. Any problem? Oh, okay. make perfect for you. Yeah.
Yes, 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 yes. If you want to do
But sometimes the specific course is dropped. Because strange number. Yeah, not used very often. Oh, 对。
If you have the account to the edu roaming, maybe you can check out. Ah, okay.
Yeah, so yeah, yeah. Okay, so, okay.
对吗？对吗？可能是 export。
Sometimes if you have virus protection software over there, any questions? Yeah.
And any
Yeah.
qualification?
Yeah.
Still?
Okay. Yeah. Nice to have you here and share the experience between us. Yeah.
Yes, okay. So I guess if anything, further question, Dr. Chan, email address, then just ask, just send the email.
Okay. Thank you, everyone.
We conclude this session. Thank you.